Now the symbols that we use over there, the electric symbols. Let's talk about symbols. There are certain symbols assigned. We'll talk about them. Cell, my source. The source, a cell, is represented by this symbol over here. You can see a bigger line, a smaller line. The bigger line represents the positive terminal of the cell. Cell has two terminals, one is positive, one is negative. If you have a cell at your home, you can take any cell which has been exhausted and check there. On the cell, each cell there is written positive at one end and negative symbol. Positive and negative symbol is given. So one end is positive, one end is negative. So the symbol over here for the cell, we use two lines, one is bigger, one is smaller. The bigger represents the positive end and the smaller represents the negative end. Remember this thing, symbol you should take care over here, because further we'll study about that also. So here this is a symbol for cell. Next we can see about load, my bulb, electric bulb. Whenever we want to represent a bulb at any point in the circuit, we represent by this curly figures. You can see the figure of a bulb over here. There is some difference between there are two types of figure for bulb. This is the bulb figure over here, and suppose the bulb is glowing, we show some lines over here around the bulb so that we can indicate, okay, my bulb is glowing or my bulb is switched off. So we can identify, we can differentiate between both the figures over there. So this is the symbol for a bulb, electric bulb. In the circuit we use the symbol over here for bulb. Then switch, for switch we use this symbol, two dots and a line. Now this switch is on, switch in on position, we call it closed switch. Remember, switch on in the circuit is written as closed switch. Remember this thing. So closed switch, both the dots are connected with a straight line. You can see over here the straight line and the two dots over here. So this is a symbol for a closed switch. Same way for an off condition. When the switch is off, we call it as a open switch, and the open switch is represented again the same two dots, but the difference is it is slightly above. You can see a gap over here. This is the condition when my circuit is broken from somewhere, means there is a gap in the circuit, the continuity of the current will not be maintained. So the switch controls to switch on or switch off. Okay, so this is a symbol for a switch off condition, or you can say or call it as a open switch. Open switch means switch off. Closed switch, closed switch is on and open switch is off. Remember to differentiate between the two things. Then battery, most important thing. Sometimes in spite of one cell we use multiple cells. We can use two. You must have seen at your home in your remote control uses two cells generally. In your clock it is one cell. Okay, and certain devices you are having some wireless system or some this cordless phone at home, and these devices, even certain toys, all battery operated toys, they are using more than two cells. Somewhere battery is also used over there. So whenever more than one cells are used, the combination of two or more than two cells are used, we call it as a battery. You must have heard battery, mobile battery, cell, both are same thing, both are giving you electricity, both are the source of my electric current. But what is the difference between a cell and a battery? Cell is a single, but battery is a multiple cell. I can say two or more than two cells. I can use 3, 4, 5, any number of cells as per my requirement. Okay, so if the cells are connected one after another, now connecting of the cells, there is one very important thing. When two cells are connected, remember the positive end of one of the cell is connected to the negative end of the second cell. Remember, I can't connect two positive at the same time or two negative at the same time when I'm using it as a source. So remember that whenever you are using cells in series, I can call it as a battery. Two or more cells, I can say dot dot dot. It means I'm using 2, 3, 4, any number of cells as per my requirement. And if I'm how to connect them, be sure the positive of the first is connected to the negative of second. Remember this thing. So cells, when we are using a combination of two or more cells, it is called as a battery. So whenever you study about battery, whenever you read about battery, in the vehicles, in the car, truck or there, we are using battery, not a cell. a big box type thing you must have seen over there. It has cells inside it. There are 4, 8, 12 cells. They are connected in series in that, and that combination is called as a battery. Even at your home in the inverter, attached to the inverter we have a battery, not a cell. That is a battery. Okay, so that battery has cells inside them. Okay, they are connected in series one after another, and that combination completely is called as a battery. Okay, so battery is a combination of cells in series. And then wires, connecting wires from one device to another, from the cell to switch, switch to the load, load to back to the cell. We have wires. So wires are represented by straight lines. Straight lines, we sometimes curved also will see, but generally to make a circuit we show over there straight lines. These are the conducting wires, I can say. Remember, these wires are of which material? They are metal, and in metals also they are generally of copper or aluminium. They are good conductors of electricity. The best conductor of electricity is silver, but silver wire too expensive, not to maintain. So we use copper next to it. After silver, copper is a good conductor, then aluminium is also a good conductor. So generally we are using copper and aluminium wires for making the circuit, for making any wiring at any place. We are using copper and aluminium. Okay, so to represent a wire we use straight lines. Okay, so now this diagram, now summary of all together at one place makes an electric circuit. This is an electric circuit diagram. You can see over here we have a bulb, we have a cell, we have a switch, and all are connected by a wire, connecting wires. So this is a complete circuit, and this circuit is open electric circuit. Why am I calling it open? See the switch condition, it is off, open circuit. The bulb is not glowing. The bulb doesn't glow in an open circuit. Okay, so this is an open electric circuit and this is a closed. Can you see the difference? The bulb glowing, switch on, it is a closed electric circuit. Difference: open, closed, open, closed. You can see the difference over here. The moment you switch off, the bulb goes off. Switch on, bulb is on. So that is the difference. Okay, so this is a simple circuit diagram which consists of my load, my source, my control circuit, controlling device, my switch over here. We can use many more devices. More devices are used in a circuit. You will study that also in higher classes. More things are there. But simply how to draw an electric circuit. Now this, I am confident that I can draw this thing, and you can also draw this thing easily. Symbols. Okay, so these are the electric circuit. Now I think you must have understood that we need a path for the current to follow. The path is called as an electric circuit. I can represent an electric circuit on a paper by using symbols. I can draw it over there. Okay, so that was about an electric circuit. So now in electric circuit, some of the points that you should remember, you should know that the key, whenever you are drawing a circuit diagram, whenever you draw a circuit diagram, this key over here, I can place it anywhere. Anywhere in the path, I can place this key. It's not necessary that it has to be here only. I can place it anywhere. My circuit breaks at anywhere, my circuit is off. The path is discontinued at any point, my circuit is off. So it's no need that it has to be here only. Okay, in the circuit it can be at any place. So the key or switch can be placed anywhere in the circuit, and when the switch is in the on position, it means the load is consuming that charge, the electricity, and the bulb is going to glow. When the switch is in the off position, or we call it as a closed circuit, when it is in a when the circuit is said to be closed, when the switch is on, and when the switch is off, we call it as an open circuit. Okay, so these points you should know, these things about an electric circuit. So now proceeding forward, let's see what an electric current can do, what things it can do. You must have seen at your home electric current, many devices operating on electric current, your AC, your refrigerator, your geyser, your toaster, your music player, everything works on electric current. But on what concept does it work? So there are different concepts. Let us discuss a few of them. What an electric current can do. So let's see a few of them. First is it can produce heating effect. It means electric current can produce an heating effect. It can also produce magnetic effect. It can also produce chemical effect. So there are three basic effects which at present we are going to explore. Out of these three also, these two are main at present for you, the heating effect and the magnetic effects due to electric current. Let's first talk about heating effect. Have you ever felt the heating effect of current? Suppose any device which is working on electric current at your home, and after some time you can sense the heat from it. For example, your television also, when it works for a certain while, when it is on for a certain while, then you stand nearby, you can sense the heat from it, heating effect of current. Even certain bulbs, the incandescent bulb which we used previously, it was being used, nowadays we are not using that bulb, it also produced heat. We can see about them.